Okay, all right. Review, FST. We're going to be reviewing here over the next few days or so, but I'm going to post a video early. It's Monday, the Monday before Memorial Day, so we have over a week. I'm going to post this today. If you find this, you have over a week that you can review for this if you need to. I already posted the review sheet as a PDF on Schoology, so if you want to print that off and follow along, it might make it a little bit easier. Okay, so anyhow, so we're going to do this all in class, but I thought I'd go ahead and tape right now. I'm into class right now here on Monday, and because you guys are all virtual right now, so I thought, well, let's get our videos done so I don't have to make any more videos this year. Okay, question number one. They give you the function f of x equals 2x to the third plus 5x squared minus 3. They want to show that there has to be a 0 between x equals -2 and x equals -3. There must be a 0. Well, so we got to plug in -2. So 2 times -2 to the third plus 5 times -2 squared minus 3. -2 to the third is -8. So 2 times -8. 5 plus 5 times -2 squared is +4. Minus 3. 2 times -8 is -16. 4 times 5 is 20. Minus 3. -16 and 20 is 4. 4 minus 3 is 1. When I plug in -2, we get an answer of 1. Plug in -3. So 2 times -3 cubed is 5 times -3 squared minus 3. 2 times -3 cubed is -27. Plus 5 times -3 squared is +9 minus 3. 2 times -27 is -54. 5 times 9 is 45 minus 3. -54 and 45 is -9. -9 minus 3 is -12. And you're not quite done, okay? Why must there be a 0? 2 words. There was a sign change. It went from +1 to -12, okay? Whenever something goes from positive to negative, it has to go through 0, okay? So we showed all our work, and then you need to say there, and on the test it might say, must there be, or not necessarily be. So if it was +1 and +12, there might be a 0, there might not be a 0, we don't know, because there wasn't a sign change, okay? So you're gonna have to show whether there is or isn't a 0 between them, okay? You still do it the same way though. Rough graph of y equals -x to the third, plus 3x squared, plus 10x. We need to factor this thing. We're going to factor out a -x times x squared, -x times -3x, and a -x, whoops, I should have an x again, right? Yes, it does. -x times -10, and we can factor it further. -x times 2 sets of parentheses, x and x, last term's negative, plus and minus, times to -10, add -3, +2 and -5. So my zeros are at 0, -2, and +5. So 0, -2, and +5. This is third degree, so it's going to be going, it's not going to bounce anywhere. It's not raised to an even power. Third degree, so it's S-shaped going down. So it's going to go like this, this, this. Just a rough graph. How far down do you go? I don't care. How far up do you go? I don't care. Okay? Number 3. Yeah, I see 5 from. All right, number 3 is a much quicker one. It's already factored for you. So we have y equals x squared, x plus 2, x minus 1 squared, x minus 2. So my zeros are 0, -2, +1, +2. It's going to bounce at 0 because it's squared, it's raised to an even power. It's going to bounce at 1. So let's graph these. We have 1, 2, 1, 2, 0, -2, +1, +2. It's going to hit at all those spots. What degree is this? 1, 2, 3, 4, 5, 6. It's 6th degree. So 6th degree. So it's going to be a parabola, sort of a parabola opening up or down. Since it's not negative, it's going to open up like this. So it's going to be like this. Does it bounce at -2? No, it doesn't. It goes through. It goes down some. Goes up to 0. At 0, it bounces, so it goes right back down. Goes up to 1. It bounces at 1. So it goes back down again. And then it hits 2, and it doesn't bounce. So now again, should these all be right next to each other? Not necessarily. I mean, we could have done this. Could have went like that. You know, it doesn't matter. Okay. I mean, I just want a rough graph. Rough graph. Number 4. Okay, sketching some of these graphs. Y equals 5x plus 3 over 3x minus 7. Okay, these ones you're going to have to study a little bit, okay? I know this is a tough section. So, my vertical asymptotes, okay? There's only one. What makes the bottom 0? +7 over 3, which is the same as 2 1/3, okay? Horizontal asymptotes, if you remember. And I will give this to you, okay? I will give this to you on the test. if the degree of the top is bigger than the degree of the bottom, there's none. There are none. There are no vertical asymptote. The degree of the top is smaller than the degree of the bottom. It's the x-axis. It's a vertical asymptote. Okay? If the degree of the top equals the degree of the bottom, then it's the lead coefficient over the lead coefficient. Okay? So, degree of the top is 1, degree of the bottom is 1, it's the same, so you take the lead coefficient over the lead coefficient 5/3, which is the same as 1 2/3. So let's plot these. Okay? Vertical asymptote's at 2 1/3, so about there. Horizontal asymptote's 1 2/3, so around there. Okay? X-intercepts. This is something you got to know. This is something you have to memorize, okay? X-intercepts, you plug in 0 for y, or what makes the top 0? What makes the top 0? -3/5. Y-intercepts, you plug in 0 for x. If you plug in 0 for x, this goes away, it's left with 3. 0 for x, that's -7, so -3/7. So our x-intercept's -3/5, which is about there. Y-intercept's -3/7, so about there. Okay, remember there's two areas, to the left and to the right of the vertical asymptote. It's either above or below. It's got to be below, that's where the dots are. Okay? And it's either above or below. It's got to be above because otherwise it would create another x-intercept, and there are no other x-intercepts. So, not easy questions. These questions 4, 5, and 6. Once we get to logarithms, I think logarithms are a whole lot easier. 4, 5, and 6 is probably the toughest question on the test, I think. Okay? Most work on them, at least. Let's look at number 5. Number 5, so we have f of x or y equals x plus 4 over x squared minus 4. I'm going to factor that right away. Y equals x plus 4 over x plus 2, x minus 2, difference of squares. Vertical asymptotes. What makes the bottom 0? 2 and -2. Horizontal asymptotes. Degree of the top's 1, degree of the bottom is 2. So the degree of the top is smaller than the degree of the bottom, so it's the x-axis. The x-axis is my asymptote, my vertical asymptote. And then we have a 2 and a -2. Okay, my x-intercepts and my y-intercepts. My x-intercepts, plug in a 0 for y, or what makes the top 0? -4. My y-intercepts, plug in a 0 for x. If I plug in 0, this is going to be 0 plus 4, which is 4. This is going to be 0 minus 4, which is -4. 4 over -4 is -1. So it's going to hit at -1. X-intercepts at -4. Okay, so there and there. All right, so we have 3 sections, to the left, to the right, and the middle. Okay, the middle is the easiest one. Okay, the dots below, so I mean it can either be S-shaped or a parabola. It can't be S-shaped because it's going to create another x-intercept. And if it's a parabola, it's got to be a parabola opening down. Because if it opens up, it's going to cross the x-axis. So it's got to look sort of like that. Okay. Over here, this doesn't really help because it's on it. Okay, it's on the x-axis, on the asymptote. So let's go over here. I'm going to plug in a number like 100. If I plug in 100, 100 plus 4 is positive. 100 squared is positive. Take away 4 is still positive. It's positive everywhere. So it's going to go above the x-axis. Okay. This is a little bit tougher one. Okay. I don't know what's going on. First off, it's not a parabola. Okay, because it doesn't bounce at this point. Okay, it doesn't bounce. So what's happening between -4 and -2? Let's plug in -3. If I was plugging -3, -3 plus 1 is a positive 1. -3 squared is 9. Minus 4 is 5, 1/5. So here it's at 1/5, so it's up here. So it's got to be going like this. Okay, it doesn't bounce, so it's got to cross over. Now, this is what's weird about it. It crosses over, but it's got to approach this, okay? So, it can't go down like this. It's got to go up, but it's going to get very close. It's not going to actually touch it, okay? It's going to go down, or, again, you cut it on this. You got to want to like that, and then have it go like that. I don't care, okay? It's got to swing back up, though, eventually and hit it. Or not hit it, come close to it. All right, that's a tougher one. I think 4 is tough. I think 5 is tougher. Okay, number 6. Last one of these, then we'll start talking about some logarithms. Number 6, we have y equals, I'm going to factor this. All right, now 2x squared plus 4x minus 48 over x squared plus 3x minus 10, I think it says. Yep. Okay, so let's factor this thing. take a 2 out, so x squared plus 2x minus 24. So x squared is x and x. Last term is negative, so plus minus. Times negative 10, add positive 3, positive 5, negative 2. Okay, we can factor the top a little more. X plus 5, x minus 2, x and x. Negative, so positive negative, times the negative 24, add to positive 2, positive 6, negative 4. Okay, so my vertical asymptotes are negative 5 and positive 2. That's what makes the bottom 0. The horizontal asymptotes, degree of the top and the bottom are the same. Okay, so you take the lead coefficient, divide by the lead coefficient, 2 over 1, which is 2. So we have vertical asymptotes at negative 5 and positive 2. Horizontal asymptote is at positive 2. X-intercepts and Y-intercepts. Okay, X-intercept, what makes the, plug in 0 for Y, or what makes the top 0, negative 6 and positive 4. Y-intercepts, plug in 0 for all these X's. I think it's easier to plug it in up here. You're left with negative 48 over negative 10, which is a positive 4.8. Negative divided by negative is positive, 48 divided by 10 is 4.8. So X-intercepts are negative 6, 1, 2, 3, 4, 5, 6. And 4, 1, 2, 3, 4. Y-intercepts 4.8, 1, 1, 2, 3, 4, 0.8. This one should be a real simple one to graph, okay? So we got 3 areas, to the left, to the right, in the middle. Points down here, so it's gotta be down here somewhere. Ooh, don't do that, that was terrible. Same thing here, points down here, it's gotta go like that. And for this one, it's up here, so it can't be S-shaped to create another X-intercept, so it's gotta be sort of like a parabola. Going like that. Okay, that's probably the easiest one of the 3, actually, I think. Okay. All right. Logarithms. These will be a lot quicker, a lot less work. On the back of the worksheet, number 7, write as a log. Okay. So it says 2 to the 4th is 16. So you say the log base is 2 of 16 equals 4. That's the only acceptable answer. Remember, what's together, 2 and 4 split up when you rewrite it. For part B, it says the log base 3 of x equals 5. So base is 3, split these up, 3 to the 5th equals x. And you can simplify that, but I don't ask you to. Just write it as a log, or without a log. Number 8, solve for t. So f equals d plus b to the at. Solve that for t. So first thing you're going to do is subtract d. F minus d is this, f minus d equals b to the ba to the t. You want to get t by itself, let's divide by b. F minus d over b is f minus d over b equals a to the t. Be careful, if it said at, you just divide by a. But it's not at, it's a to the t. So let's rewrite this with a log. Log base, my base is a of, split these up, f minus d over b equals the exponent, which is t. And we're done. T's by itself. Okay? So I solve for t, you have to use an a log in order to solve for t. All right. Number 9, these are quick ones. Okay. What's the log base 7 of 1? 0, because 7 to the 0 is 1. Anything to the 0 is 1. Part B, log base 12 to 12, that looks terrible, is 1, because 12, not 12 times 1, but 12 to the first is 12. Log base 7 of negative 3 is nothing. You can't take the log of a negative. And 4 to the log base 4 of 7. 4 to the log base 4 of 7. Remember, these just cancel against the 7. I don't expect to see it work on that. Okay. Number 10. Solve log base 7 of x minus 2 equals the log base 7 of 3x minus 10. Okay, since they're the same log bases here, you can get rid of the log base 7. So you have x minus 2 equals 3x minus 10. And let's subtract x to each side. You do that, we have negative 2 equals 3 minus x is 2x minus 10. Add 10, negative 2 and 10 is 8, equals 2x, divide by 2, 8 divided by 2 is 4. You gotta check your answers. If I plug in 4, 4 is good. 4 minus 2 is not negative. 3 times 4, 12 minus 10 is not negative. So the answer is 4, it does work. Okay, I'm not gonna make you don't have to write out your check, but if it's not a correct answer and you don't cross it off because you forgot to check it, you're gonna get it wrong. Okay. Number 11, solve log base 3 of x minus 4 equals 2. This one should be a quick one. Write it without logs. 3 to the power of 2. And again, the reason why we can't get rid of the log here, we can get rid of it here because there's the log on each side. There's only a log on one side here, so write it without logs. 3 to the power of 2 equals x minus 4. 3 squared is 9. Add 4 to each side. 9 and 4 is 13. And you don't have to check this one, but if we do 13 minus 4 is good because it's not negative. 12. Expand. Log of 4x over y squared. Okay, so we're timesing and dividing and we have powers. You can do all three rules on these, okay? So I'm going to do the timesing part and dividing part first. So the log of 4 times, when we times we add, so plus the log of x. Then we divide, so we subtract the log of y squared. And then we move that 2 out front, not all the way out front here, just in front of that. So it's the same as the log of 4 plus the log of x minus 2 log y. Okay? All right, number 13, condense. Do the opposite of what we just did. We expanded, now we're going to condense. So number 13, we have 2 ln x plus 3 ln y minus 4 ln z. Okay, so I take this 2, make it an exponent, make this 3 an exponent, make this 4 an exponent. So you have ln x plus 3, I'm sorry, not 3, ln y, ln x squared plus ln y cubed minus ln z to the 4. Right, there's one natural log. When we times, we add, when we add, we times, and when we subtract, we divide. So it'll be x squared y3 over z4. You only get to write natural log once. When you condense it, you only get to write the word log once. Okay, 14, 3 more to go. Solve. Log base 4 of 3x plus 2 equals the log base 4 of 5 plus the log base 4 of 3. Okay, so let's do this. I can simplify this side. The log base 4 of 3x plus 2 equals, when we add, we times, so the log base 4 of 15. 3 times 5 is 15. And since we have log base 4, this is no different than this question, I already erased it. It was question number 10, I think. We can get rid of these log base 4s. We're left with 3x plus 2 equals 15. Subtract 2. 3x equals 15 minus 2 is just 13. Divided by 3. 13 divided by 3 is just 13 thirds. And if we check that, if I plug in 13 thirds here, 3 times 13 thirds is a positive, plus 2 is still positive. Okay? 2 more to go. 15 to 16. Okay, 15. So we have the log of x plus 2 minus the log of x equals 2 log 4. Okay, so I can simplify this side. I write it as 1 log. When we subtract, we divide. So the log of x plus 2 over x equals 2. I'm going to take that 2 and move it up here. The log of 4 squared. Since we have log base 10 here, log base 10 here, we can just get rid of them. We're left with x plus 2 over x equals 4 squared, which is 16. I'm going to clear my denominators. I'm going to times each side by x. These cancel. X plus 2 equals 16x. Subtract x to each side. 2 equals 15x. Divide by 15. X is 2 15ths, maybe. Let's check. If I plug in 2 15ths, 2 15ths plus 2 is positive. 2 15ths positive. Yes, the answer is 2 15ths. Last one, 16. So we have log base 3 of x plus 3 plus log base 3 of x plus 5 equals 1, I think. Okay, so let's condense these. When we add, we times. So the log base 3 of x plus 3 times x plus 5. We add, we times. Let's write it without logs. We can't just get rid of the logs like we did previously because we had a log on each side. Here we only have 1 log. So 3 to the first equals x plus 3 times x plus 5. 3 to the first is 3. FOIL this out. X squared, 5x, and 3x is 8x. Last is 15. Quadratic x supposed to equal 0. Subtract 3 to each side. Okay. If we do that, we have 0 equals x squared plus 8x. 15 minus 3 is 12. We factor. X squared is x and x. No negative, so plus plus. Times to 12, add to 6. 2 and, times to 12, add to 8, which would be 2 and 6. So it looks like our answers are negative 2 and negative 6. It looks like they are. Let's check. If I plug in negative 2, negative 2 plus 3 is positive 1. That's good. Negative 2 plus 5 is positive 3. That's good. Negative 6 plus 3 is negative 3. That's no good. So just negative 2. Okay, so again, you have, let's see, hang on this thing. Okay, you have until next Tuesday, over a week, that you can study for this. If you have questions, I'm not saying you have to study every day for the next week, but you have potentially 7-8 days you could study for it. If you have questions, email me or talk to me in class when you see me in class. All right, see you.